Well, in this video we will describe the end behavior of this function. The end behavior depends on two things: the degree, which in this case is degree 4, and the leading coefficient, whether or not it is positive or negative. In this case it is negative. What we know is when the degree is even, the end behavior either looks like this or like this. When the degree is odd, the end behavior either looks like this or like this. And this is the positive version, this is the negative version. Positive, negative. Since the degree is 4, we know we are dealing with one of these. Alright, we can forget about this. Since there is a negative in the front, a negative leading coefficient, we know we are dealing with this version of end behavior. So, translating this into words, okay, on the left and on the right, the end behavior. If you look at this model, okay, you could say that on the left, you know what, let me just keep it really simple, and I'll just, instead of writing down on the left, I'll just write left when I say that. On the left, it falls. Okay, that's this. And on the right, it falls again. Alright, on the left it falls, and on the right it falls. So as I translate this into formal end behavior, to get this aspect that says on the left, I would say as x approaches negative infinity. Okay, that's the left. Okay, now if I want to say the function falls, I will say the function approaches negative infinity. That's the falling part. Alright, now if I want to say on the right, I will say as x approaches positive infinity. That means as we head towards the right. Now if I want to capture this falling on the right business, falls, I would say the function approaches negative infinity. So you can use the colors to see how each one of these parts represents these ideas. So now I just have to find out which one of these has it. Now be careful, because these are backwards from the way I usually write it. I usually write x and then y, which is what this is, and they have y and then x. So just as a quick scan, so we're looking forward to say negative infinity, negative infinity, negative infinity, positive infinity. Okay, I'm purposefully sort of tracking it backwards from the f of x to the x. So negative infinity, negative infinity. Okay, so the first one has that, alright, as f of x approaches negative infinity, x approaches negative infinity. So far so good. Now as f of x approaches negative infinity, alright, so I need negative infinity twice on the f of x. Let's see how many of them have that. So this one does not have negative infinity twice on the f of x side, so you can forget that. This has positive infinity, so it won't be that. This has positive infinity in there, so it must be D. Alright, it's the only one that has f of x with the two negative infinities. So let's see, as f of x approaches negative infinity, x approaches negative infinity. Okay, and let's see, as x approaches positive infinity, f of x approaches negative infinity. Okay, so D, even though they've written it backwards from the way I like to write it, D matches what we have said.